So today we are going to discuss one of the again very interesting problem statement, which is called spiral matrix. Without wasting time, let's go and read the problem. So spiral matrix, this is the problem in LeetCode, very popular problem. So we will try to understand what is this problem all about, and then we'll try to see how we can solve this particular problem. So given a m cross n matrix, written all elements of the matrix in spiral order. So what does it mean? Like, for example, let's say you have this matrix, then you have to do like spiral like this. So you start with 1, then go to 2, and then you go to 3, 6, 9, 8, 7, and then you go reach to 5 in a spiral mode. Similarly, like this is a spiral mode. So whenever you make something like spiral, so this is the way you always moves up to the center. So you have to print the output in such a way that it is following a spiral order, and that's what is expected in this particular problem. Um, so let me quickly code this in terms of how the problem statement looks like on a very high level. So let me write the class name like spiral matrix. Okay, so now we have main method into this. I'll copy this spiral, control C, and I just add this here. This is all good. And then I copy this input array. So here we have input, logic, output. And yeah, so when it comes to input, um, we just copy this, and this is a double dimensional array, so I'll do, and then I just replace with curly braces. All right, so what is the logic? So when it comes to brute force approach, so uh, what we can do, okay, let me go to the problem statement again. So as I said, always try to explain the interviewer your brute force approach, and then code the solution which is optimized version. Don't code the brute force, you can just explain, taking 1 or 2 minutes. So if I have been given this particular interview question in front of me, so I'll start this way. So spiral order, I understand what is this spiral order, what exactly it means. I will try this spiral traversal by tracking visited cells. So what I will do, I'll create, let's say, a result array, okay, and in that array I will keep on storing all the elements which I'm visiting, and making another matrix array which is, let's say, visited, and every time whenever I move right, down, left, up, so I always make sure that uh, whenever I am just visiting anything, any single element from the original matrix, I make sure that in the visited matrix I mark that particular item as visited, so that I do not repeat it again, right? And you know the order, which order we always move. So for example, when we move to right, we can move to down, we can move to left, we can move to up. So you see here we are moving to right, and then we can move to down also. Diagonal is something which we are not moving. We moving left, and then we moving up. So these are the 4 directions possible. So I can also make sure that I have somewhere these direction marked or fixed, so that we do not make anything wrong when we calculate the indices for our elements. And yeah, so it will be all good. So um, I trade this whole matrix in such a way so that every element is visited, and we mark those visited elements into another matrix, which, let's say, visited matrix. So, and my for loop, one single for loop will run till m cross n. I mean, this is the brute force approach, right? So uh, there will be only one loop which will be iterating from I0 to m cross n, like total number of elements in the matrix. And then we are just adding result dot add, like, because I create a resultant array, resultant list, where I will add the final result. So result dot add matrix, let's say, my indexes like x y coordinates of every element, so x comma y, so matrix x comma y will be added, and x and y will be calculated based on the directions that we are marking, right? So moment we store result array with matrix x comma y, we also marked visited x comma y is equals to true. Why? Because we want to make sure that we do not traverse this item again. And then, as I said, x and y, these are the coordinates for an whenever you move in a path, so meaning right, left, down, up. So every time when you mark get x and y, you always make sure that you are changing the direction, right? And in order to change the direction, as I said, you have to we can maintain a direction array which will be fixed 0 1 0 comma minus 1. And that's pretty much all. I mean, I think that's pretty much all we can do to solve this particular problems in a brute force approach, right? So you might be on wondering. Let me quickly kind of give you a high level logic for brute force, because it is very important. It is very, very important for us to understand what is brute force approach. So as I said, I'll make a list of integer which will be a result array. I'll not code all, but yeah, just making some pseudo code. And then I also make another array which, let's say, boolean matrix, and let's say I call it visited. And then I will make another I would say uh, one dimensional array where I'll just mark directions, so that I always know which directions I have to move. So 0, I can move down, I can 0, and then -1. So these are the all directions: right, down, left, and up. It's very important to understand. Let's say, imagine this whole matrix in a x and y. So whenever you have x and y axis, so you have at the center 0 0, right? So whenever you have at the center 0 0, so what are the directions possible for you in a matrix to move? For example, when you say right, okay, so from 0 0, if you want to make a right, you do not have to. So right means you have to move to increase the column, okay? Row will be same, so 0 comma 1, this is right. And then similarly for left, for down, so in down, what you're doing, you're increasing the row to down. So 1 comma 0, and column will be same. And then we have left. So what we are doing in the left we are saying the row will be same, but we are decreasing the column, meaning we are moving to the left. So this is left. And then we have up. In up, what we are doing, we are kind of decreasing the row, and then column would be same. So these are the four directions which are possible, right? And how we will get these directions? We will get these directions with the help of our direction array, and this is where these are going to play the very crucial role, right? So let me explain you uh, this particular direction, okay, how it is going to be used. So as I said, I have result array in my brute force approach, and then visited array. This result array is where I'm storing, meaning whenever I'm visiting a single element, storing it into this for my final answer, and then marking in visited array that this particular xy coordinate and the element at that coordinate has been visited, so that we do not repeat it again. And then direction array is something which we use for our direction purpose, like which new x and y coordinates will be, which will be the new um, directions, right? So let's say I start with x, which, let's say, current coordinate, current x coordinate. And then let's say we have y, which is current y coordinate. And then something called I can say something called x nx, which will be my new coordinate, nx, and ny, which will be my new coordinate. And these coordinates will always be calculated uh, using directions, this particular array. And what we will do in order to calculate, so for example, this will definitely use this, so I can write this. So for example, nx x coordinate of nx will always be considering current x coordinate plus direction of um, mm, um, dir. So let me I will just say, I mean, just to iterate on this direction array, I can create some dir index, which is 0. So this dir will be my nx coordinate, and then ny can be calculated as um, dir like y plus d directions. and then dir plus 1, and then I can do percentage 1, percentage 4. Okay. Yeah. So this percentage 4, uh, you might be asking here that why we are doing this, meaning like why this percentage 4 is there. It is very important to understand why this, because this percentage 4 is used to ensure that the direction indexed dir cycles back to the start when it exceeds the boundary, okay, bounds of the direction array. So for example, um, let's say we have these directions corresponding to 0, 1, 2, 3 index, and after moving up direction, let's say dir value is 3, which is at -1. Okay, the next direction should cycle back to dir equal to 0, because after 3 you should not increase it to more than 3, because we have only 4 possible directions available. So that is why this percentage 4, it prevents out of bound indexing, and that is why we use this. Okay. So uh, and incrementing directing indefinitely will always cause array index out of bound. So I hope you got this. So yeah, that is the reason why we are using the, and when we have this new x and new y coordinate ready, then we can just have some condition that, hey, if my nx is, let's say, less than 0, meaning it is kind of the new x and new y coordinates are kind of very close to the boundary, and y is, let's say, also less than 0, or similarly nx is greater than equal to n, similarly ny is greater than equal to n, and then this particular thing visited, meaning you already have not visited nx and ny. So this, if this has been visited, so all these conditions should be true, and then only we say that, okay, this is the time to change direction. So I will increase my dir with dir plus 1 and then percentage 4, because this is the time when we have to change the direction. Um, so these are all conditions over here, like line number 26. All conditions here, they are simply saying that, hey, while moving to the matrix, I moved to this particular point. I cannot cross this, right? So if I cannot cross this, the final column. Uh, Similarly, when we are talking about rows, so I cannot, when I'm going upwards, so I cannot cross this row. Like this is the final row, I cannot cross this row. So row less than equal to 0, I cannot go. So all these indices, whenever we are doing this, when reaching or those edge cases, we have to change the direction, and that is the reason why this condition is very important to check. And then we also need to make sure that this direction percentage, this will make array index of out of bound. Let's say when we are increasing direction dir index more than 4 times, because we have fixed number of elements, so we cannot go infinite. Moment we are crossing the, it should go back to 0 again. Yeah, so this is pretty much all over here. When this condition is true, it is the time to change the direction for me, and then I can use this, as I said, the same formula here inside this if condition, and in the outside I can say this is my n x new, like x and y coordinates will be updated to n and y. And then that's pretty much all. I think that's pretty much all we can do uh, to solve this question in a brute force approach, where we are kind of using an auxiliary matrix to mark our elements visited, and then when those elements are visited, it means we do not have to visit them again. We have to change the direction, right? Uh, so this might be looking quite red. Let me quickly do this way. I will quickly uh, code this brute force solution, which is very important to understand, and then I will also explain the optimized solution, because this that optimized version of the solution is also very important, right? So let me quickly code this new array list. All right. So let me import the class, and then, as I said, we will be creating a Boolean visited matrix, which will be again a new Boolean m n. And let me quickly do this m and n in the very beginning. Int m is equal to matrix dot length. These are number of rows. And similarly, int n is equal to matrix 0 dot length. These are the number of columns. That's pretty much good. I have direction array created in a good way. I have my um, indices to handle the direction array is already also created. I have my int x equals to 0, and I also want to start my y equal to 0 because these are my beginning starting level coordinates. And then this is all I shared with for you, the explanation. And yeah, I just don't need this because I just need a for loop here. So let me quickly create a for loop for I, and there I will say m cross n. It is very easy for me to code faster this time because I already explained you the code here. So now what I have to do, I just need to add into the result, as I said, result dot add, and over here I will say matrix x comma y. Moment I am adding it, I must also mark this x visited array, okay, as true, because I do not want to visit it again. And then this all calculation which we have done here has to be done. So for example, this calculation is very important. I will just say, hey, calculate my int new new x and y coordinate. And then when we are done with this, I think I can remove this code, and I just need to copy this um, and move it here. Yes. And I can remove all this from here. Yeah. So you see, this condition is all looking good. I just need to put this x and y, they are updated to the new coordinates. Direction is also updated to change. I mean, this is the place where we are changing direction, change direction. And why we are changing direction? Because we are very close to the boundary, right? Or let's say because the element which we are checking is already visited. So we do not need to visit it again. Change the direction. And that is the reason why we are changing direction here, right? Okay, so this is all good. And then here we just s- just to result, and we can run this problem solution and see how it works. So you see here 1, 2, 3, 6, 9, 8, 7, 4, 5, and what is the expectation? 1, 2, 3, 6, 9, 8, 7, 4, 5. 1, 2, 3, 6, 9, 8, 7, 4, 5. So you can see this solution is very simple, straightforward, and very easy. It's not very difficult. Whenever you have problem like this, you just need to understand what is the approach you have to follow. So this was a question, the approach which was connected to this. So whenever you have matrix and you have to move in the direction, always make sure that you need to decide, when I reach to the edge case, what should I do? So over here, this is my very important statement which says, hey, I'm reaching to the edge case. What should I do? Either should I, terminate, or I should just change my direction. So this is the example where we have to change the direction when you reach a particular edge, right? So for example, when you reach here, what should I do? Move to the left. This is where we are just using this, and this direction, why we are doing percentage for is because this is a finite array with 0, 1, 2, 3 index, and when you cannot go dir plus 5, like when it go to plus 5, you need to come back to either 0, or like you have to rebounce the index back to the beginning of the array or somewhere which it lies. So that is why we have to be very, very careful with this. And storing answers, marking is visited. When we have visited array, already an element which is visited, change directions, and then these are my x and y coordinates which will always be marked. So this is a solution which is good, and this is time complexity is O of m cross n, because you see here this is my um, array, and then we are iterating it m cross n times, right? Um, Now, coming to the part where we are kind of optimize this solution is that we can do it without auxiliary matrix. What does it mean? It simply means that whichever this visited array we are planning, we can solve this particular problem without having this visited array. I can give you a hint of this. So what I'm trying to explain you that uh, let's do it without having visited array. And how we can do that? So we can do that in by storing the results. I mean, everything will be same. It's just that I'll be removing this visited array, and then I will be iterating it. For example, I traverse from left to right first, okay, and then from top to bottom, and then right to left, and then from bottom to top. And every time I do this, I make sure my left and bottom and right and all those indexes are all good. And then and pretty much all. I mean, that's pretty much all I can. We are sorted here, and we can solve the problem the same way, right? So what I'm trying to explain is I'll quickly code here the optimized version. So I'll just copy everything which we have here so that I can save time, and I can just let me park this in a method. Okay, so extract method. Let me name it to spiral root force. All right, and then I let me create another one which is spiral result one, spiral optimized. Yeah. So now I will make this. Will copy this same method just for you to, and there I will just rename it to optimized. Yeah. So this is my method. So what I'll do, as I said, I just remove this. I remove this. I remove this. I remove this. Okay. And yes, this is all good. And then I need my top left. So int top equal to 0. Bottom equal to matrix dot length minus 1. Okay. And similarly, I will write int left equal to 0 and right equal to matrix 0 dot length minus 1. All right. So this is for column, right? I can remove this also, not needed. And now what I have to do? So instead of for, I will say, let's say while, and there I'll change the conditions to the important condition. So what it will do, top left is less than equal to bottom. Okay. And left is less than equal to right. All right. And then should have here four for loop. So this is first for loop. Let me comment it like left to right. Okay, traverse. And this is what is called I less than equal to right, and it will start from left. Okay, and there, which what we are doing, we just adding this result, right? And there I will say I, and then sorry, it will be I, and then this will be the top. Okay, so I just need to remove everything which we have here because they don't make any significance, and I just need to copy this 4 times because we have 4 directions. All right, so you see here, this is my left to right, and then I increase my top plus plus, and then we have to do from top to bottom, because left to right, left to right from top to bottom. Okay, so in top to bottom, what we have to say, we have to start like top, and then we have to move to bottom. All right, and then it will be I comma right, and then we have here right to left, right to left, and then we have here right, here we have left, and this time because we are making here like we are making here right to left. So for example, right to left, we are increasing this. So the indices here, I should always be greater than equal to left, right? So otherwise it will fall out of the bound. So over here, what I will do, I'll just say right minus minus. Okay. No, sorry, this will be right minus minus, and this will be right to left is, yeah. So when I do right to left, we also have to make sure, very important thing, that if my top is less than equal to bottom, okay, then only I'm doing this right to left. And inside this also I'm kind of making bottom minus minus. Okay. And then I copy this and I have to do it for the last page, which is like bottom to top. So I copy this, bottom to top, and there I would say left, right, and then here I will start with bottom to top. So we start with bottom, we go to top, and that is why we are saying like I is equal to 0, and then we are uh, the I should be greater than equal to top, right? And that's what exactly it means. It should not go beyond the index which is there, and then it will be I, and then it will be left, and over here left plus plus. So I'll explain you one more time. So let me quickly format this code. Yes, it all looks good. And let me quickly just print the output and see how the solution behaves. So this is fun. And I run this solution. Okay, so there is something wrong. Let me quickly check what is wrong and which condition is breaking. Okay, so my top is less than equal to bottom and left is less than equal to right. That's good. Then I equal to left, I less than equal to right, I plus plus, result dot add matrix top plus plus, I is equal to top, I less than equal to bottom, I plus plus, matrix I right. All right, top is less than equal to bottom, I is equal to right, I greater than equal to left, I, okay, sorry. So this is where I'm making the problem. This is where I am supposed not to do this. Yeah, so when we are starting I is equal to right and we are making right to left, right? So what we are doing, we are moving from right to left. So we are decreasing the index of the column, right? So that is why we have to decrease this and now run it. So you see here the okay, so the order is little bit changed and I need to understand what went wrong. So top is less than equal to bottom, I is equal to right, I greater than equal to left, I minus minus top. So instead of this top, I would say it should be bottom and then matrix I left. Okay. So now if I run this, sorry, it is something here. Okay. Now I run this. So you see here, the solution is exactly matching. So you might be wondering what these indexes are and how these indexes are playing the role. So I will quickly explain you one more time how these indexes are working so that you get an idea about like how we can avoid this auxiliary. So because sometimes it is very important for you to understand to save the space also, right? So I will quickly explain you about all these indices. Um, and let me explain all indices and how they are working. So and it might be difficult for you to understand like why we are doing top plus plus, right minus minus, bottom minus minus, uh, and all right. So let me quickly explain with example here. So let me start with the very first thing, which is left and right, right? So I think guys know what is left and right. So left and right represent the current bounds of the column, and top and bottom represent the current bound of the rows. Okay, so this and this line is clear. Then initially top is the 0 because we are starting from the row, and bottom is m minus 1 because end of the rows. All right. Similarly, left equal to 0 meaning start of the column, and then right equal to matrix, I mean n minus 1 which is end of the column. Now let's say we have initial variables like top equal to 0 and bottom equal to 2, okay, and left equal to 0 and right equal to 2. So what we are, top equal to 0 and bottom equal to 2. So we are 0 and bottom equal to 2. So we are at 0 1 2. So this is the place where we are having. So and then left equal to 0 and right equal to 2. Let's say these are the variables. So what exactly does it mean? So when we say this iteration first time here, so what it do, we move along the top row from column left to column right. Okay. So what we are doing here, left to right traverse. So we are moving from left to right. So it means we are moving from left to right like this. So whenever we are moving left to right, we are adding all those elements. Okay. And we are increasing the I. That's what we are doing here. But also when we are done with this loop, what we have to do? We have to increase the top. Okay. And why we have to increase the top? Because we move along the top row from column left to column right. So this is the top row, and we increase the top row so that next time it goes, the top row is this, not this, right? So that is why we are doing. So after this step, we have finished the top row. So increment top to move to the next row. So this row is done. And now the top row is pointing to the second row. And that is the reason why I have this top plus plus. Now, top to bottom. So what we are doing here, now we are moving from top to bottom. So over here you see rows are changing. So what we are doing, so you see here I here matrix I, this indices point to the row, and we are starting from top to bottom. Okay, and this is changing, and now over here what we are doing right minus minus. Okay, so this is the index for right. See, top is means the topmost row, bottom means bottommost row. I mean, these are the boundaries, as I already said, right? So these top and bottom, they represent the current bound of the rows. Okay. Similarly, current bound of the columns are left and right. So now why we are just doing right minus minus? Because this is the when we are done with this, we have to move this right uh, bound to move to the this place. So this is the rightmost bound, and now we move it to -1, and that is why we are doing it right minus minus. All right. Now right to left. What exactly it means? So for example, let's say you are kind of moving from right to left like this. Okay. So you are moving right to left. Uh, so. Uh, So first what you have done, you have moved left to right. So when you move from left to right, and now right to left, meaning you are doing this iteration like 9, 8, 7. So when you are moving this direction, so once you are done with this, what you have to move? You have to take the bottom minus minus. Yes or no? So that is why over here we are doing it bottom minus minus. When you do right to left, 9 to 7 we go. When we are done with this row, we move bottom -1, and that is why we are doing bottom -1. So bottom minus minus, and this is very simple condition, right? So we should always perform this iteration only when top is less than equal to bottom, right? So this top is less than equal to bottom. It should not cross the boundary. Similarly, the last one here, bottom to top. So when you are moving this way, so let's say when we are done with this, so what we have to do when we are done with this, we have to say left plus plus, because we have to move to this particular column. So we are doing left plus plus. So that is pretty much all when it comes to this particular solution. I hope you liked it. If not, you can comment. Please subscribe my channel to share such videos and explain you with real code, real live coding. Let me quickly post this. I mean, this particular solution, of course, have time complexity of O of m cross n, but space complexity is O of 1, right? Because we are not using any visited auxiliary matrix. So see, this is very simple, can be done. If you can play around with pointers, moving directions, go with this optimize, you can save some time. If not, then brute force is also good here. So let me paste this here. Okay. So let me run this. All right, this is accepted, and submit the solution. Here we go. So the solution is submitted. Thank you very much. I see you in another video.